check a microphone. Hello, everybody. How are you doing? My name is Laura. Thank you so much for coming to this session today. Couple of bits of housekeeping. What I do is slightly chaotic and a little bit different than you might see elsewhere. If you have questions, I know there's a lot of languages in this room. I'm speaking English and I don't speak Norwegian. If you do want to ask a question but you don't feel confident to raise your hand, please come and find me afterwards. We'll have a nice slow chat. I want to make sure that if you do want to get deep into something, you feel comfortable to do so. Right, without further ado, we will get into it. So this is me. Actually, this is what AI thinks I look like, because having my photo taken is the most excruciating thing known to man. So Tanya has volunteered to torture me for the next hour by taking my photo. I have been a software developer since I was 16, when I was a COBOL developer in the UK. Don't do that as a first job, that's a bit weird. I've done everything from radiation monitoring software for CERN in Switzerland, through to deep government work, penetration testing, and for the last 15 or so years, I've specialized in going very fast and doing security. So I've written a couple of books. My mom is proud. That's about all we need to say about those. But I'm the person you call if you have a software team and it's all slightly chaotic. You don't have an AppSec person yet. You have many languages, many frameworks, many software applications, some of which you even know where they are. I'm the chaos person. So whereas there are people here speaking tomorrow's keynote, for example, from Google, and they're at the very big end of town, I'm at the opposite. And the beauty of that is what I do is very dynamic, and it forces me to be very creative with where I get my data from, with my approaches, because, well, when you don't have an AppSec team, or any money, or any time, or any management support, you sort of just have to figure out how to get it done. Now, I just want to get a bit of a show of hands here. Raise your hands if you work for an organization that has an AppSec person. Raise your hand still if you are the AppSec person. Oh, I'm sorry. Is there anyone in the room who is at the other end, who's like, I'm a developer, but the security thing matters, and oh my goodness, where do I start? Oh, hi, welcome. You are absolutely welcome. Right, so in this talk, I'm going to take a bit of a journey with you. We're going to talk about the power of developer-centric data. Now, I think I win a prize for NDC Security, as I had the only talk title that overflowed the talk title field in the app. So, yes. I'll explain what I mean by developer-centric data. I'm also going to show you some bits of really terrible code so that you can use yourself to do this if you wanted. Even better, go to a talk by someone like Jim Manico and get AI to help you write this code. That'd probably be better than mine. I'm going to talk about predicting AppSec issues, and we're going to talk about prioritizing security activities. Now, I'm not here to give you the, very magic-filled wonderland that is the perfect AppSec program. I want us to really dive into software and look at what's going on and the patterns we see, and a few of our biases on the way. So let's start off with the power of developer-centric data. So why do we need data, specifically from software development, to do security? And I'll explain. This is an SDLC. There are many like it, but this one is mine. This is a standard cyclic flow. Now, I don't care if your organization goes around this circle 20 times a day or once a year. I don't care if you are Agile, DevSecOps, Scrum, Scaled Agile Framework, or any other particular brand name of software development. I don't care. What I care is that people in your organization take technology, they throw it together like a crazy Lego set, and build something awesome. And it goes through these kind of steps. I see those frowns in the face. They do build awesome things. You just need to believe in them. Right. Now, this is all good and all, but we have two different teams playing together here, right? We have the software team, and the security team. Now, I'm a bit weird. I live in both. But let's talk about what drives each of us. So software people, what do we want to do? We want to innovate. Cool. I want to do new stuff. I want to build things. I want to design things. I want to find all of those stories that I read in sci-fi books and turn them into real things. That sounds like a really good idea. Or work for a bank, whichever. I want to accelerate. I want to go fast. Like, I don't want to, some of you will like details. There'll be details people in this room, especially at a security conference. But on the whole, we want to go fast. We want novel challenges. We want that dopamine hit of, yes, I'm doing a cool thing. And we want to improve our code. Now, I have a fundamental belief that software engineers want to build high-quality code. I don't think anyone comes to work today and goes, you know what, I'm just going to phone it in, and it's scrappy, but, you wouldn't be an engineer. If you don't enjoy building good software or building amazing technology, there are better ways to make money right now. Try plumbing, for example. So we want to improve things, and we improve them in a set ways. So in software, we'd often call these things like the ilities, which are the characteristics of high-quality software. So observability, performance, scaling, accessibility, usability. And security has to fit in with that definition of quality for them. Now, on the other side of the equation, we have, oh, hello. I feel like I'm doing magic spells now. Right, cool. On the other side, we have security people, of which many of you will count in this. Now, we want to we want to stop bad things happening. Cool, great. There's a lot of them. It's hard work. We want to detect that bad things are happening. So if, Tanya goes wild and decides she's going to destroy the place, I want to know it's going to happen right now, right this second, so that I can do something about it. And then I want to respond. If a big bear walked through this door right now, which is not a thing in Norway, I've been told, but I am from New Zealand, so who knows, comes through the door and decides it's going to try and eat the lovely gentleman in the stripy jersey, then I need a plan. What am I going to do? Now, secrets, did any of you go, oh, right, the man in the jersey, I'm fine, I'll just walk that way? Anyone? No? Just a couple of you. So security teams want these things. Now, what happens when these two worlds collide, as we already know, is friction. We have a misalignment of expectation, of motivation, of reward system. And as a result, things get a bit hairy. We have been trying for a number of years to put security through development life cycles. I've been talking about this now for close to 15 years. And the fact that we're still talking about it tells me that we all suck at our jobs. But that's okay. What do we do right now? Well, right now, we take a development lifecycle, we find a security tool, so SAST or DAST or IASP or RASP, or insert your acronym here, and we pop it into the lifecycle. Now, we do this with really good intentions. It's kind of like trying to give a gift to the dev team. Here, take this tool, put it into your life cycle. It will make you more secure and happier and better. Raise your hand if you think this goes well. Do you sell tools? No. You never know. And what happens is we put the tool in. If we're lucky, it gets run. And if it runs, we get our reports out the other end and warnings and notifications. And if we survive all of that, we review the security findings, we prioritize, we remediate, and we loop. Now, fun story. The first time I put a SAST product in for a fintech company, we put it in and very enthusiastically went, we don't need to put it in monitoring mode. We'll just put it in enforce. And on the first pass, it found 67,000 issues. That was a fun day. Our security data can be very, very useful, but also to a development team, it sits completely outside of their world. What you do is you bring in a magic box and say, your baby is ugly, and this box is going to tell you how, and then we walk away. And then the reports happen, and then we give these findings back to the dev teams to then fix. And that's not ideal either. But it gets worse than this. Because our dev tools assume that we all have a blissfully well-configured, predictable deployment pipeline that has been built lovingly and with care and has all of the right parts in it. And there's just one of them in the whole organization, this blissful utopia. Any of you live in utopia? No? No, me either. Best case scenario, you have lots of deployment pipelines. And in the case of banks and telcos and large organizations that have, particularly those who've grown by acquisition or merger, these probably all look completely different to each other. And they're run by different teams. And some of them you don't even know about. They're somewhere over there. I met a telecommunications company in Australia a little while ago, and they had acquired 1,800 organizations over the life of the company. I could not quite fathom how many applications they had. In fact, they didn't know. They couldn't tell you how many pipelines they had. Now, that's a bit of a problem when I go back to our plan of we'll put a security tool in your pipeline and everything will be fine. Because what's happening here is, as security people, we're focusing on a what problem. We're focusing on code, the code we can see right in front of us. There's a build pipeline, go fix that one. We're not really digging into the how. How is this software built? Now, the how is really, really important. Secure coding is essential, I'm not going to argue that, but it has been done to death. There are a million talks out there about SQL injection and cross-site scripting. Great, go see those. What I want to talk to you about is how we can shift our attention from the code to the life cycle and our approach to get better at security. Good. I call this implementation-focused security. Now, for those of you who've seen me talk before, I do talk a lot about how we build software. I'm fascinated by process and structures and teams. And what I really enjoy doing is trying to look at the way we think about things and finding the bias in them. So let's start with the first one. The bias in our security tooling right now is it assumes that all software projects are active and in development, which means they're going to be built. Because, you see, to run a software tool at the moment for security, it goes into the build pipeline. And to trigger the build pipeline, you have to trigger a build. Raise your hand if you, in your organization, have at least one project or system that isn't in active dev anymore. Nobody's building that thing. Yeah. Raise your hand quietly, and I won't judge, if you don't even know if it would build if you tried right now. I like a good, honest group. Yeah, those ones terrify me. So, in these cases, our bias is starting to really unfurl this security approach, right? We could have bought one tool for every pipeline we have, but if your pipeline never builds, you're never going to fail your report. Fabulous. See? Security finding number one. Never run your security tools and you'll always pass. So what happens is this. We'll have some that run all the time because they're in active development. We'll have ones that get built, so new pipelines spring up, and those happen. And gradually, as projects go from being in active development to more maintenance mode, the build frequency slows down, till eventually it stops. Or, in some cases, you don't even have an automated pipeline at all for that one. That one is built by somebody at the command line on a laptop that hasn't been built since 2002. So there's a pretty big bias. So it's like, this can't be the only bias out there. So bias number two, that our software projects are all independent of each other and that all supply chain risk comes from external third parties. Now, I particularly like this one because it's built around the idea that the only code that is harmful to you is that outsider code that comes in from, other places. I live on a tiny island in the middle of nowhere. Like, we have this weird relationship with things that are outside of the island. Same in software. We tend to think all of our pipelines are completely independent of each other and have no relationships, but they don't. The components you build in pipeline 1 may well be dependencies you rely on in pipeline 2. And so, whereas you might say, well, this pipeline over here, it's failing and it never builds, but it's all on its own, so that's fine. It's not the case. Because if that becomes interconnected, if it's coupled with other pipelines or other systems, then that transitive risk that we're very concerned about from our third-party libraries becomes a very real internal problem. Bias 3, all tools and processes are applied consistently across all projects. Absolute fallacy. The number of security tools that are purchased, lovingly installed, and then the first opportunity turned off is astoundingly high. The number of tools that are renewed, not because they're being used and useful, but because nobody knows where they are anymore, and they're not making any noise, so nobody thinks about them. Very high. And that means even if you did have the same tool in every pipeline in this dream situation, well, you wouldn't really have much of a useful finding set anyway, because only 2 of them are properly configured, 1 of them's in monitoring mode, and the rest, the engineers put a temporary exception in because it was breaking the build too much and they had a deadline. Now, I've been on both sides of that. I've been the engineer that puts in the exception. I've also been the engineer who looks at it and goes, how long has that exception been there? And does anyone know? Oh, clicker. I believe in you, clicker. Yes, I just have to do it with like energy. Right, bias number 4. There is a difference between legacy and non-legacy code. No, there is not. Today's production code is tomorrow's legacy code. How many of you have been writing software or been in software for a little bit of time? Perhaps we have the name senior or principal in our job title. Yes, me too. I hide it with hair dye, mostly. How many of you have software projects that you wrote early in your career that you hope have been thrown into the sea and are no longer running? Yes, absolutely. Like I said at the start, I wrote radiation monitoring software when I was 23. That's insane. Never ever get a 23-year-old to write real-time C++. It's a bad idea. Your legacy code is not legacy. It's not this like grand thing we cannot touch. It is foundational. It is the thing the other systems are built from. If you're in a bank, it's probably made of things like COBOL, and I don't say that in judgment. I say that in a startling reality check, that you've probably got a list of vacancies to support that code, where your biggest problem to hiring is that the people who can do the job are dying. We are at that stage of legacy. Now, the thing with this is we say often that, oh, well, legacy code is different. We'll protect it in different ways. Maybe we'll surround it with things. But the problem is, if you look at this with a developer mindset, everything couples back to this. So if you were to look at the connections between all of your systems as a big graph with nodes and edges with data flowing through it, this legacy part isn't separate. It is part of the whole. And so we need to stop talking about legacy code. We need to figure out how to include it in the mix. Don't worry, there's not all biases for like an entire hour. That would be tedious even for me. Yes. Bias number 5. Security tools can identify human risks, such as malicious actions, mistakes, or misunderstandings. Raise your hand if you have made a mistake, ever. Raise your hand if you just told a lie. There's a couple of you. Yeah, there we go. Thank you. We make mistakes. In fact, some of the most ingenious solutions we ever come up with are because we made a mistake at some point. You can't see right now, but I have gaffer tape literally behind my ear because I made a mistake in how I was holding this microphone on my ear, and that was the only solution I could come up with in 30 seconds before this talk started. We make mistakes all the time. And mistakes and changes in behavior, whether it's malicious, which is unlikely most of the time, or you've just had a bad day, they're important. We need to be able to have security tooling that spots the human side of things. Not so we can judge people. Not so I can say, guy in the stripy jumper is clearly evil and should not be allowed in the code base. Sorry, you've got a really distinctive jumper, it just helps me out. We need to do it so that we can be free from accusation. If we can have tooling that gives us visibility, it means that I don't have to worry that you're okay or not okay because I can see it. If something goes wrong, I know what normal looks like and I can go, hey, this is outside the normal. What's going on here? So we need that. So how are we going to do it? That's the more important bit, right? Because all these things say that we suck at something, and it's not a very positive talk to go, hey, here's some problems, good luck with that. So we'll move on a little, and we'll talk about how we can get better. So this talk is about using data we have to solve some of these biases. Now, there are 0 tools that I'm trying to sell in this, none. You will notice I've been on a booth for this conference. That is not in any way related to the content of this talk. I'm not going to mention what I do. But there is stuff here that you already have in your organizations, in places you just haven't looked yet, that could paint a really fascinating picture of how to prioritize and approach your application security. So today, we focus on securing the code we are building. What I'm going to encourage you to do in the remainder of this talk is moving to securing all of the systems that we are building now, that we have built prior, and we will build next, because it's about all of them. There is a step that's missing in almost every application security program and framework. And if you came to Tanya's talk earlier, you'll know some of those frameworks now. You'll have gone and looked them up because you were paying attention, and that's a good thing to do. That step is finding all your software and making a list of it. It's not in any of the frameworks. But that's the future. The future is actually protecting the chaotic, beautiful mess that we have, not just the one we're building right now. So it's not about adding new things. I'm not going to tell you to go and spend any money at all. Just don't do it. I want you to adapt what you already have and get more value from it, which is like KPI dream if you're in performance review season. So, hold on to that. So how are we going to do this? Let's look at how we can use some data to predict some AppSec issues. Now, this all started in a funny place, and I will explain the story of how this talk even came to be. But what I've learned over my career is every tool we use, every single tool, collects an astonishing amount of data. Now, how many of you use Google as a service, so for Gmail or whatever? Have you ever really sat down and thought about all of the data that Google has about you? It's fascinating. I mean, it's terrifying, but it's also really interesting. Google probably knows my mood better than I do, because it can see what music I'm listening to, how quickly I skip things, how fast I'm walking, everything from my wake-up time to my sleep time. Because all of my accounts are interconnected, it can probably tell you about, my family and how that all works. It's fascinating. So if we know that all this data is here, we can't change that, so let's use it. So we're going to look for some patterns. So I'm not going to get huge maths data nerd on you, because none of you need that, and also you're all smart cookies. But we're going to look at some kind of patterns in data. We're going to look for data diversity. How different is this data? Frequency, how often does something happen? Recency, when did it last happen? The number, how big or small it is, and consistency. Is this thing happening in a way that is predictable and repeatable? And we're going to look for changes in these. Are we looking for things that are decreasing, getting smaller, less frequent, less numerous, less diverse? It's not always a bad thing if things are decreasing. Or is it maintaining? Or is it increasing? It's getting bigger, it's more frequent, it's more prominent, not always a good thing. We're also going to talk about delta and delta change, so the change over time. I think change over time is a really underused sort of data. How much are we changing? Is that delta increasing, decreasing? So where did this all come from? Well, last year, when I should have been doing something more useful, like running a company or whatever it was I was supposed to be doing that day, looking after a child, instead, I was sat there thinking, is there a way to use our metadata from software development processes to identify security risks in systems? Now, I probably need better hobbies, to be honest, but this is what I was thinking about. And so I started thinking, can I look at project composition? So by project composition, I mean, if you were to look at a software system or product, can you look at the metadata of that product and go, right, can I draw a picture, build a profile of this, just from the data I have? So what technologies are in use? How many lines of code does it have? What's the build mechanism? What's the delivery cadence? All of these things. I was like, cool, this data is all in there. I know it's there because I can see it in the dashboard in places like GitHub. So I was like, cool. So with the help of my friend Copilot, we went off on an adventure. And off I went. So the nice thing about developer tools is they're built for developers, so they're almost always API-driven, which means you can query all sorts of wonderful things, and you don't need fancy permissions. I didn't have to give myself admin access and crazy, read-write permissions to everything. I was just asking it, hey, GitHub, can you give me some stuff? So I authorized myself, fantastic, easy, and notice, look, I didn't even put my token in the code. Look at me doing security. I was like, okay, tell me all the repos in my org. Great, easy. It throws out a giant lump of JSON at you. I mean, JSON isn't my favorite data format, but it's super easy to work with. And from this, you get all sorts of wonderful things. And the nice thing about this is it is ridiculously well documented. So what could I look at? Well, in a single API call, I could figure out the number of distinct technologies used in a project. Now, raise your hands if you know how many languages are in your organization right now. How many? All of them. That's a fantastic answer. I love that answer. All of them is the best answer. I once, on a security job, came into a fintech, and on day one, they were like, we're a Java shop. I was like, cool, great, I know Java, this is wonderful. By day 2, I was on 17 languages, and we'd found a strange version of Erlang that they'd forked. I was like, oh, cool. So, diversity of technology is really interesting. The perception you have of the technology that's in your company isn't necessarily the technology that's in use. And it's much easier for us to prioritize and find risks. So, for example, if we're following open source technologies to find out if there's been a vulnerability, if we know the diversity of technologies. Also, it means you can create a little heat map. So you can say, okay, cool. We've got sub-communities, almost like a Venn diagram inside your software. Right, Python people, you're all over there, and we've got .NET over here, and somewhere in the middle, there's a Go crowd, and there's one guy in the corner that's doing Fortran, and we don't know why, but we love him anyway. And that means when you're coming to share security advisories or do remediation, you're not going, hey, developers, here are things. You can say, hey, specific group of developers for this technology, here's something you really need to care about. And when we're targeted in that way, it's much more effective. The other thing that we can infer is looking at skill set. Now, if you have dozens of technologies, and you're switching technologies all the time as an engineer, the knowledge of each technology is likely, and I'm generalizing, to be shallower. Because you're moving technologies all the time. I move languages fairly frequently because I have to when I move between customers. But that means that my knowledge tends to get really deep very quickly and then get very shallow. It kind of goes up and down and up and down and up and down. If you're a kind of homogeneous organization, you've only got a small set of technologies in there, it's much more likely that all of your engineers are going to be quite deep knowledge-wise. So you can use this to your advantage. You can understand the skill level and maturity. Now, I asked you earlier who were seniors, and I've got a lot of seniors in the room. This is particularly important for senior engineers, because senior engineers often have to dabble in lots and lots of languages, which means their knowledge can be shallow, or it can be hard to keep it up to date. That's not a judgment, but it's something we can remedy and say, hey, okay, here's how I support you. Also, the higher number of technologies, the higher the chance of supply chain risk. If you're, in the NPM world, cool, you've got 2.3 million different packages. If you're in NuGet, you only have 200,000 to worry about, but each of those packages is 10,000 lines long. So, whatever your language set you have, each one of them is going to have its own risks. So the more languages, the more you're going to need to be on top of that supply chain risk. Let's look about lines of code. Isn't it fascinating, lines of code? I love looking at people's code bases. It's kind of like looking through their drawers. The number of lines of code in a project or repository is really interesting to me. The bigger it is, the less likely it is somebody knows all of it. It's kind of a base deduction, but it works. And the bigger it is, the more likely there is to be a security vulnerability. Raise your hand if any of you are involved in code review. Yeah? Oh, you all look so happy. Oh, it's fun, isn't it? And when you're given a huge change to review, are you happy? You know, thousands of lines of code have all been massive, giant pull request. Oh, halcyon days. No. And the bigger the pull requests, the bigger the repositories, the less likely we are to actually find the vulnerabilities in them. Because it becomes very difficult for us to do things like reachability, to trace through the code, to analyze all of the things. This gets even worse if the number of lines of code is high because there's loads of commented out sections, because nobody likes to ever delete their code. Raise your hand if you know that's the case in your team. Anyone? Why do we not trust our version control systems? It's literally, they have one job, and that's to bring back the code once you screw up. So delete it. Makes your life a lot easier. So I'll give you a recipe. This talk is full of recipes, and you can get the slides off me at the end. So if you want to use this kind of data, I would look for the following combination of things. To identify a decaying project. So a project that is no longer as loved and is at higher risk of security issues because it's getting less attention. So we're looking at a build frequency that is decreasing, a pull request frequency is decreasing, and the contribution community is reducing. By contribution community, I mean the number of different developers who are contributing to it. Now, you can see this in open source if you like. You can go and look at a project and see the community go smaller over time. Now, if a project is decaying, this is a really good opportunity for you to say, hey, okay, right, we need to give this a bit of love. Because if this is decaying, if it's getting less attention, then those tools we mentioned at the start, not being run as much. There are less eyes on this code. So it's a good way for us to go, cool, this thing is getting stale, let's lift it up and make sure it's more recent. Then I looked at pull requests, because pull requests are really interesting. The way that we encapsulate and divide our code changes, the theories and the methods that different teams have for it, there's an entire cultural dynamic around this. I looked at things like reviewer diversity. Do all of your pull requests get reviewed by the same single person? Or does everyone review everything else? Is there a submitter diversity? Now, that's an interesting and contentious one. What if you've got a team of 10 engineers and one of them never, ever submits a pull request? That's interesting to me. Why? Can anyone ponder why it would be interesting if a developer never submits a pull request? Well, I'm assuming they're doing something all day. So how's that code getting to where it is? Something to go and ask. It's kind of like being Sherlock in your own little repositories. Recency, the size of them. You want to be doing the same sort of look. So let's look at, again, an example. Pull request reviewer diversity, the percentage of the team reviewing requests. The lower the percentage of the team, the bigger the reliance on a small group of people, and the less code knowledge is spread amongst the team. Also, if that person gets poached by Google next Tuesday, you're in trouble. We call that a key person risk. Now, it's a very human risk, that. I'm not talking about your syntax. But raise your hand, actually, just be honest again. You're a really lovely, honest group, so I'm going to get you to raise your hand. How many of you feel like there are systems or things in your organization that would have a really bad day if you just won the lotto and never came back to work? Yeah. I love doing that. When you look at a real system and you go, okay, cool, there's only one person in the whole organization that could actually fix this if it broke. Yeah, we want to find this. This, for me, is horror stories in the making. We should fix it. So my querying continued. I was like, well, what about people data? Can knowing who is working on projects and how they behave help with security? Now, full disclosure, I did a talk at Black Hat in 2015, and you can find it online. And one of the bits of feedback I got was that I should probably be in prison. And that talk was about pulling people data together and inferring security outcomes for a larger organization. It's actually, I'm not an evil person, but watch the talk one day maybe. You can tell a lot about the security of an organization by the structures between its people and how they interact with the code bases. So team size, contribution frequency, pattern of life, like what time of day do you submit your pull requests? So for me, for example, I do my best code work first thing in the morning. So if you see me submit anything after 2 p.m., I guarantee it's a festering mess. Some of you will have opposite patterns. Your best work happens at 2 a.m. But that pattern of life is really interesting. Why is it interesting? Well, because if you see me commit something at 2 a.m., that's not me. I sleep. I like sleep. It's one of my favorite hobbies. We can look at project-to-contributor ratio. So what if gentleman in the hat at the front, it turns out he's contributing to every single project in the organization. Like, whew, goodness me, that's a lot of permissions. Now, why is that interesting from a security point of view? Well, with your evil hat on, just put it on for a second and imagine, well, if we know this gentleman has access to all the repos, then that's the account that's going to have the most valuable things in it. Like, that's when I want to go compromise. So hopefully we've made sure that they have two-factor on their access to the deployment pipelines, and perhaps they are definitely subject to review or to alerts when they contribute to things, or even better, we just take away all their toys and take away all their permissions. That's my favorite. So we can look at that people data, and it's all available via that API in GitHub or in Azure DevOps or in GitLab. It does not matter. It's exactly the same data. We can look at all sorts of combinations. So, for example, on individual contribution frequency, the lower the frequency, the less recent their knowledge. And now this one's an interesting one for degradation over time. So if, for example, I was contributing every single day to a project, you could safely say my knowledge of that project is quite recent and it's probably growing. But if over time I stop contributing as frequently, and now I'm just like once every couple of months I go back in and do a thing, all of that knowledge begins to fade. There's no judgment, that's a human thing. We've got other things in our brain. And so it's a muscle memory that is then starting to weaken. So if you can spot people whose contribution frequency is lowering over time, these are probably the people who have the least knowledge, or they're the people you need to give that little support to get them back in. We can also look at that project-to-contributor rate in more detail. So it's really interesting to interpret community dynamics inside your repos. So go and have a look at who's working with who always reviews each other's work, who leaves the nastiest comments on a pull request. Go look at all of those contribution dynamics. So I'm going to read it because I want to be very specific, and it's a really interesting one to kind of jump into. But in some instances, the contributors may be spread too thinly. So, for example, the hat guy is in every repo. Now, they're being exposed to a wide perspective of the organization, which makes them incredibly valuable. And sometimes they then become an architect. That tends to be how we create architects, is they see everything and then we give them a crown. Or it can go the other way, where they have the idea that they know a lot of things, but the knowledge is very shallow, and so they're very dangerous. So it's that jack of all trades, master of none thing. You can cause a lot of arguments in your team with this set of dynamics. So please be careful with this data. Use it in a blameless way. Talk about it as patterns and not as individuals and finger pointing. So here's a recipe, identifying the key person risk in your team. So if a person is in a high number of projects, they are responsible for a high percentage of pull request reviews, and they have a high rate of pull request submission across a high number of projects, this person is being Batman. Now, what's the problem with Batman? Burnout. Yeah, well, burnout, absolutely. Headhunted, absolutely. Well, let's think about the Batman thing a little bit deeper. So Batman's in Gotham City. There are 5 crimes going on at once. How does Batman decide what he's going to do?
What's most fun?
Yeah, well, in Batman's case, yeah. And the rest get put on the backlog, and JIRA tickets are raised, and then he'll go to prioritization in 2 weeks' time, decide which crime he fights next. That's how it works. If somebody is doing all of those things, they are trying very hard to be all things to all projects. We don't want that. There are no superheroes in software, and there are no superheroes in security. What there is people doing the right amount of work, the right time, and sharing responsibility. That shared knowledge is power. If this person leaves, if this Batman character leaves, or they burn out, or they actually start having a bad day, if they I'll explain it. If they have children, I'll come back to that in a second. Problems. Now, I know the children one personally because when my youngest was tiny, I went from being an absolutely kick-ass developer overnight to being the worst person on my team. And that's because on my drive to work, my then one-year-old daughter would do things like learn to open the windows and start throwing things out while I'm driving. And so by the time I got to work, I was so stressed and tired that I was a terrible developer. Now, people's lives are complicated. You're going through stuff, which means you're not going to be on your best form every day. So if you have one of these high contributors that suddenly something changes, that can be really problematic. Then I got even nerdier and said something, Conway's Law. Raise your hand if you know what Conway's Law is. So this is a security conference, so we've got like a weird mix of dev and security in the same space. Does anyone want to feel brave and say what it is? I saw a few raised hands. Go on, go for it. No. It's like, no. All right, I'll give you the definition. It's very old, the theory of Conway's Law, but it's used a lot in software engineering to explain the dynamics that appear in code bases. Any organization that designs a system defined broadly, so as in system is a broad definition, will produce a design whose structure is a copy of the organization's communication structure. So if your organization is horribly siloed and nobody talks to each other, your applications you build will model that communication structure. If your organization is very collaborative and interconnected, your systems will tend to be hyper-collaborative and communicative. If you're a very vigilant organization, then you will see that. If you are blameless, you will see that. And the same is true in security. So if you want to really understand your developers better, look at what the code base tells you about the communication systems in your team, because you might actually learn something from that. So if I'm going to really stretch this analogy and just take it as far as I can, why not? Let's go all in. Let's look at the business, because the business itself can tell you a lot about AppSec. So the revenue model, regulation and compliance, the company's health, strategy and priorities, organization structure. Now, what on earth do any of these have to do with AppSec? Well, these things are what drive your development team. So if your revenue model favors, selling to thousands of customers over thousands of verticals, you're going to have a very different risk profile and different development cadence and number of requirements changing than if you serve 2 customers and you always have for 10 years and you know them inside out. If company health is bad, and in the last 12 months, it's been rough for many software organizations, then often we see sad things happen like restructures. And when a restructure happens, the team gets smaller, but the workload doesn't. So if the company health fails, you can guarantee that developers are feeling more stressed. More stressed, more to do, which means that when it comes to vigilance and processes and all of the things we rely on to keep our code safe, to maintain those ilities, they start to degrade too. Strategy and priorities. They feed through to the requirements that hit our teams, which shows us how long they're going to spend on things. So looking at that data, not in isolation, but in relation to how our development teams work together and communicate, the cadence and velocity they work at, even down to their pull request frequency and contribution rate, is a powerful picture. So I'll give you an example. Any of you work for consultancy software firms? So places where you build software for other organizations. Oh, one of you. If you do end up, it's a very different way of working. So one of the key metrics you'd want to look at in those kind of situations is the percentage of billable hours to maintenance hours. Now, in a consultancy or in a service organization that builds software, you are billed for the number of hours, they are billed for the number of hours that are worked on the project. However, there are expectations that those hours are being spent on functionality changes, improvements, not necessarily on what's seen as housekeeping, so security. And in fact, in many arrangements, the security isn't even an explicit requirement. It's just sort of assumed you did it. If you're seeing the number of billable hours is very high, but the number of maintenance hours of that is very small, you've got an escalating problem. So you're building lots and lots and lots of new code, and you're spending very, very little time fixing the code you have. So that can be a big challenge. So if you're in the type of environment where you do measure like velocity story points, for example, you can substitute that for billable hours. If you're seeing all of the story points focused on new innovation, rather than maintenance, BAU, bug fixing, technical debt reduction, then you've got a bit of a challenge. I see pained pictures on your faces, and I'm like, oh, I feel like there's stories. You should talk to me afterwards. Regulatory and compliance scoping. Oh, my goodness. Right, so how many of you are in regulated industries? So finance, medicine, government. You live in Europe. Yeah. OK, cool. So you know this one. The problem is, when regulation became mainstream, one of the ways to manage regulation burden is to scope the systems that are in scope or out of scope for the regulation. So, for example, in the case of PCI DSS, the Payment Card Industry Data Security Standard, you scope the systems that are involved in payment transactions, and everything else is not important. Only the PCI systems are important. Now, that's really interesting to me, because it means you've got this like little golden community of systems here that we treasure and we protect, because they've got this precious things in them. And then we have the Wild West. We don't need to care about those because they're not regulated. You don't have to do compliance on those. It's super, super dangerous. So we need to really, really be careful and use our data wisely. How many of our systems have been declared out of scope for compliance or regulation? Now, I don't particularly like regulation or compliance for many reasons, and that's a conversation over a beer at some other time. But using it as a scoping mechanism in this way is really, really, really dangerous. And so we've got to be really careful. So if you are in that environment, then please do pay particular attention when somebody says it's out of scope. There is a famous poster from a New Zealand hacking conference about, I don't know, probably 12 years ago now. It was a list of hackers don't care about. And it was a list of things hackers don't care about when they're attacking your system. And one of them is that it was out of scope. There's no such thing for an attacker. If I wanted to attack your systems, I'm not going to politely look at the one that you've stood up with the golden padlock on the door and it's all looking great and you've had it pen tested. I'm going to look at the marketing website that's connected to it next door, or the Fitbit tracking app you built for your team that's hosted on the same infrastructure because it was cheaper. I'm going to take any path possible to get to that data. So scoping gives us that false sense of security. It's kind of like being an armadillo. So, you know, small critter, big hard shell. Tell me about an armadillo's tummy. What's special about an armadillo's tummy? It's soft and ticklish. They get really giggly. Now, if you need an analogy to peg this to, scoping gives you the sense that you're all inside that armadillo. Your attackers, all they're going to do is flip your armadillo and tickle its tummy. Right, good. Weirdest analogy you're going to get at this conference, I promise you. Right, development team turnover. Now, the number of people or percentage of the team that have left the team over a measured time period is very interesting to me. High turnover is a massive AppSec red flag. Now, it's a red flag for two kind of reasons. Firstly, institutional and project knowledge goes through the floor. Nobody knows what you're doing. And what happens? We start rebuilding systems because nobody knows how they work, so we'll build it again. That's not how these things work. Often, you're going to end up with big problems because there are unknown complexities that were previously known that have been overlooked. The other side of this is broader than that. It takes a lot of time to get an engineer up to speed and get them functional and doing all of the right things. It's really hard work. So it's a big cost on an organization. It means if you find a vulnerability, it's going to take longer to fix. It means if there is an outage, the downtime is going to be higher. Plus, then, who wants to work on a team where everyone's leaving every 5 minutes? It creates a real cultural void where the type of people who stay are not necessarily the people who are going to contribute the most or do the best work. So how do we use this for our last few minutes to prioritize some security activities? Because what I've told you is you have loads of data, and you're going to spot all of these wonderful relationships and create Venn diagrams. And it's going to be like, you know, when you watch a crime show and there's like things on a wall with lines between them. That's going to be you, and I'm excited for you. So what do we do with this? Almost every other element of security, like broader information security, already does most of the things I'm about to say. So there's nothing here that is magic. There is nothing novel. I need us to do some basics that we perhaps have forgotten about a little bit. So firstly, we're going to map all of our projects, and I mean all of them. And when I say map, I mean draw them. I don't mean like draw a picture, this is like Bob the system. I mean, get that dodgy whiteboard or a giant sheet of paper, and I want you to draw the systems and how they all connect to each other. And you're going to have to find the right people to help you with this, because it's not going to be one person. And it's not going to be a formal Visio diagram that you found in an architecture file just somewhere. That thing is a cute artifact of a time once past, if it ever existed at all. I want you to map them all. You cannot protect software you do not know exists. You cannot protect it if you don't know how it relates to each other. You can't do this without knowing the process flows. So where does data flow through this organic thing? And there are no tools out there right now that can do this nicely for you. I wish I could tell you there were. If you feel inspired, there's a huge gap there. Go do it. I started doing this. I started mapping all of the things you could map in an organization, right down to like a dev team eats 2 pizzas. So I included pizzas in case you were wondering why that was there. It gets really complicated. Now, if I had a spirit animal, it would be anxiety from inside out. That's essentially like me in the morning. For me, developers are happiness, they're joy. And they come in and they're like, we're going to change the world. And I come with my baggage and I go, no, we're not. Don't freak out when you start mapping all your projects. Just take it as it is. Just take that breath and go, look, it is what it is. It's not good or bad, it just is. The more you map this out, the easier it will be to understand where the opportunities are to start. Step 2, spot dormant or inactive projects. These are the ones that have not been built in a while. These are the ones that nobody knows how they work. These are the ones where you don't even know where the source code is anymore. And flag them. Again, no judgment. It just is what it is. Draw a big circle around them. Put a little star on it. Don't care. But those ones, at a minimum, get them built at least once. Just build the thing. Just check that you have the source code, that someone has access to it, that it still builds. If not from a security point of view, from a resilience point of view. Let's consider this disaster recovery as well as security. Next, I want you to spot key person risk. I want you to use those calls to API, or just go and do it manually via the UI if you prefer. And I want you to spot how your human architecture maps to that big architecture of systems. So, you know, does that stripy jersey person contribute to all of the things on the left side? Are there overlaps? Are there bridges? Now, there's a wonderful book on network theory and the connection between systems. It's not really about tech, it was about humans. But it talks about bridges. Now, bridges are people or systems that connect other things together. They're typically the only connection between 2 sides of a community. So, for example, if you had a karate group over here and a karate group over there, and they don't know each other apart from one person who transferred clubs and has friends on both sides. Now, if you're an intelligence agency, that's the person that you move out of the way. But if you're in software security, this is a person that is in an interesting position. They're a bridge. They're a weak, interesting, vulnerable place. Start there. Spot your key person risk. Do not make them feel bad for it, but don't reward them for it either. No heroes. Every time you find a key person risk, find at least 2 people to come shadow them and pick up bits of their role, even if it means you have to take their permissions away so that they have to watch somebody else do it for a while. It's the best present you can give yourself is to make that person upset for a little while. So you've got homework. Congratulations. So I want you to map all the things. I want you to look at the number of people identified as key risks and think about that. And if that is you, then think about that too. It's not a failure to be less important. In fact, it can be the best thing you do for your career. And then I want you to wake up those dormant projects. And then, when you're finally ready there and you've looked at your developer data, then go back to your security tools and tell me which one has never touched one of these projects, which one is never getting run or never made it out of learning mode. Because only then, when you've mapped all of these things together, can you really understand where the risk lies in your software systems. So, in summary, we have a goldmine of data, more than you will ever be able to process in your life. But we're also in a beautiful time where, using things like AI or just a little bit of innovation time, you can query these APIs and start looking at it. Don't assume that your development processes are uniform, that they work, that they're all the same as each other and not connected. Use the data you already have before you buy any security tools, because you will find gems in there. And take simple steps to improve security, starting with knowing what a crazy, beautiful mess your software architecture landscape is, because it's the most wonderful thing you'll ever protect. Right, that is me. You can download the slides if that's your jam. Alternatively, you can come and talk to me afterwards. I am vaguely friendly and even have stickers. So if anyone has any questions, we have 3 minutes left. You're welcome to ask. And if not, come find me in the corridor. Thank you so much for your attention. So, yeah, of course I can. We built a platform, it's called SafeStack, and we can help you roll out an AppSec program that is unapologetically opinionated. So what we do is we take all of the frameworks like OWASP-SAML and SSDF, and we turn them into teeny, teeny, tiny tasks that you can do, and we give you lots of guidance on how to do it as simply as humanly possible so that you can then roll out an AppSec program that you control yourself without needing an expensive consultant, and you can measure your maturity over time. And then hopefully that will give you some structure and allow your devs to feel like they're engaged in owning security rather than just having it inflicted upon them. That was very nice of you to ask me though, Tanya. Any other questions? Well, you're all fabulous, but get out.